So in the previous lesson, we spoke about depreciation, and depreciation is really how things lose value. If you do accounting, you would do a lot of this. And there's two ways that we calculate how things lose value over time. There is what we call straight line depreciation, or there is reducing balance depreciation. Okay. And sometimes instead of straight line depreciation, they call this simple depreciation. And sometimes instead of this being called reducing balance, we call this compound depreciation. And when you're calculating depreciation, you need to make sure you use the correct formula to help you. So the formula for simple depreciation is that. The formula for compound depreciation is that, where P is the initial value, A is the final value, I is the depreciation rate or the interest rate, N is the time periods. Give me a thumbs up if that looks familiar to you. Give me a thumbs down if that doesn't look familiar to you. Okay. So what you need to be able to do in all these questions is just be able to find any one of those values, A, P, or N. And so I want to start with a little bit of revision. In this question, you have to find the missing value if the straight line method of depreciation is used. And that means that this formula will be in play. I want everyone to try and do A, B, C, and D. So all you have to do is you're given 3 of the values and you have to find the 4th one. Can you do that for me? And I want to give you some time to have a crack at that. If you're completely new to this topic, don't worry, just give it the best you can. But can you work out, for example, in A, what A is, in B, what P is, in C, what I is, and in D, what N is? And if you would like to ask a question, you can just raise your hand and we can talk about that. But otherwise, see what you can do based on the previous lesson. And yeah, put the answer for A when you have it in the chat. You will need a calculator to help you along the way today. So you should have got 276.08. So basically, it started out in life being worth 680 Rand, and it ends up being worth less, 276, because of the depreciation.
Mr. S, if you could perhaps maybe zoom in a bit.
And yeah, if that helps a little bit. So some of you may be wondering in the second one, how to get P. And the biggest problem in B is this bit in yellow. It needs to get away from the P. And the way we do that is it's times on the one side, it becomes divide on the other. And so then what is the final value of P going to be for this? I have to use my calculator. I get 7848.61. So initially it was worth that, and then it lost value and it got down to 3940. See if you can do, if you agree with me, that's awesome. And then you can have a crack at C next. Yeah, so I'm going to have to, in this last line, divide everything by -7. Let's see what I get. There are a couple of different ways to do this. So your teacher might have a slight variation on this, but as long as you're getting the same answer as me, then it's not a problem. So okay, and then normally we leave this will be a depreciation rate, but it will be 6.90% per annum. So we're losing about 6.9% of its value every year that goes past. Okay, so we have done A, B, and C. Can you do the last one, which is D? What we got for that one? 8070. Oh, I'm making things up here. I have 4,300. So those are the values that you have for D. I'm just going to zoom in a little bit. Let me move this out of the way. What do we think N is going to be? For the D. You're going to have to divide both sides by the number in front of the n. I'm not showing the working out just because of the fact that there's just too much on the screen. But let's see if we all get the same answer. What are we getting for n? I don't want to give it away until students have put their answer in, but I've got my answer here. And n is going to be the time period. Yeah, so it's going to be 1.13. If you round it to the nearest year, it would be 1 or 1.13 is what you should be getting. So in doing that, to start with today, we've shown you all 4 variations for simple depreciation or straight line depreciation. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow it. I just want to get a feel for how everyone is feeling in the room. Okay. Because then what we're going to do is, once I'm comfortable with everybody's okay, we're going to move to reducing balance depreciation, which is the other way of depreciating. Okay. Awesome. So before we start with reducing balance depreciation, I want to ask you, or maybe I don't even have to ask you, what you'll notice is as we move to reducing balance or compound depreciation, the formula will be different. But there's something else that's different. The thing that's different is we're not going to depreciate only on a yearly basis. We sometimes depreciate on a half-yearly or a semi-annual basis. And so I'm going to do this first one as an example for you. How do I do it? Well, I don't know what A is. That's fine. I'm going to work it out. I know what P is. It's 6,080. Now, I doesn't actually just stay 0.077. What do you think I need to do to I to make it depreciate on the time periods that it is asking for? Tell me in the chat, what do you think I need to do to I to adjust things? It is a yearly interest rate, and to become a half-yearly interest rate, I need to divide it by 2. Now for N, I don't want my time periods to be in years if my interest rates are in half years. So I convert this to 6. So I want you to work out for me, what is the answer to A? How much does this thing depreciate to? If it started life as 6,080 rands worth of value, what is it going to be worth after these 3 years or these 6 half years? What do we think we're going to get for this? If you key it into your calculator, it's going to be less than 6,080. And what I'm getting is that. And Saskia agrees with me. So does Zayan, Nakiwe. That's awesome. So I'm pretty confident that we are all on the right. Pilo agrees. Okay, awesome. So I want you to now do for me, I want you to work out, let's have a look here. Let's do C. And I also want you to do, no, let's not do C. Let's go down here. I want us to do I, and I also want us to do H. So I want you to first do I, and then I want you to do H. So I first, the yellow one first. See if you can work out what A is in that one. And then I want you to do, after that, I want you to do H. And see if you can adapt your thinking to help you answer this question. So I see in the chat, no, Peter and I see a bunch of students agree. It should be 4389.83. So 4389.83 is how much that will be worth in the end. So it's gone, it's lost value. It started out life being worth 5,310, and then it ends up being 4389. Awesome. See if you can do H now. Now H is a little bit different. See how you can adapt the question for that. And I'm looking at the chat and I see that we definitely are all getting 867.55. Give me a thumbs up if you're understanding what's going on. Give me a thumbs down if you feel a little bit unsure. Maybe some of the compounding interval stuff is catching you or something to that effect. Okay. Let's have a look and see if there's any one that is a little bit more sneaky before we have our break here. What can be one that looks different? Let's have a look. So if I look back over these questions, which one looks a bit more sneaky? So I think what we can do is we can have a look at C. Now, if you're compounding daily, it's going to be 365 is going to be the important value that's going to help you. So see if you can do question C, the one that I'm highlighting in yellow at the moment. See if you can do that one. And then I think it's time for a bit of a break. Yeah, and we should get a value of 7252.21. Okay, so you just had to break that into smaller periods there. Okay, everyone, I like what I'm seeing in the chat, so I think it's time for a break. So let us turn our cameras on and stand up. And let's just start by stretching out our arms above our heads. Feel your body. And let's shake out your arms and swing them a little bit. Maybe give them a bit of a flap like this so that they are nice and loose. Give your legs a bit of a shake. You've done a solid half an hour of maths, and so your body wants to move. Let's start with some basic shoulder rolls going backwards like this. And then we can roll forward. And then let's do some small circles. And then let's go into some bigger circles, like you're doing the butterfly. And then change direction, like you're doing the butterfly backwards. And then let's do some small circles going backwards. Okay, and then let's do a bit of rotation. So just not too far initially, give yourself a chance to the muscles to wake up. And then you'll see that you naturally start turning a bit further. It feels nice. Okay, and let's just do tricep. Stretch that out. Like this. Oh, okay, and then let's do some heart rate stuff. Let's do air skipping today. And we'll do at least 20, and we'll start in 3, 2, 1, and let's go. Yeah, and 1, 2, 3, 4, 5. Then we're done. I hope that you feel a little bit more relaxed. I definitely do. I can notice how my shoulders feel a bit looser. And then, can you solve the Math 24 puzzle questions? See what you can do. Tati, so what we have to do is, it's a little fun game we play where we try and take the 4 numbers and we try and make 24 using just the 4 numbers on the card, and you can only use each number once. And the red one is kind of, the 1 star is like the entry level one, 2 star is harder, and 3 stars is like the hardest we get. So Owami has already, the red one actually was really simple today. We just had to add the 4 numbers together. But now the blue and the yellow are a little bit tougher. And it helps us kind of just keep in touch with our multiplication tables, because multiplication tables often are involved here. I'll give you a hint for the blue one. 7 times 5 is a helpful times table to keep in mind. What do you get when you get 7 times 5? And then there's a 6 and a 7. How do we... Actually, I don't even know if that's helpful. Would it be helpful? Because you've used up 7, you've used up 5. So that would give us 35. But now, does that even get us... I don't even know if that is helpful. So blue is actually quite tricky today. And what about yellow? These are getting harder. Oh, okay. The yellow one I think I can do. Yes, the table. Yes, yes, yes. So the table 5 plus 2 gives you 7. 7 times 3 gives you 21. 21. And you've got one more 3 left. So that gives you 24. So that is the yellow one. Now the blue one is a sneaky tough one. I wonder if there's anything else. Well, maybe we should just leave it till later in the lesson if we have time. What do we have? 7 times 6 is 42, maybe? So 7 times 6 is 42. Now, can we get... We still have the 7 and 5. 42 divided by 7 gets about 6. No, I'm still... The blue is beyond me at this stage. But 7 minus 5 is 2. I'll look at that one. 7 minus 5 is 2. And no, still not. Okay, well, I can't get the blue one yet. Oh, Kitsaw, let's have a look. What are you suggesting? 7 divided by 7 is 1. And then 1, 5 minus 1 is 4. Well done. And 4 times 6 is 24. Yes, well done. So 7 over 7 is 1. 5 minus 1 is 4. 4 times 6 is 24. Well done, Kitsaw. Well done. That is very impressive. Okay, cool. That was just a little bit of fun. Let's go back to the lesson. So the one type of question that I haven't covered so far here is the one where we solve for the interest rate. So before I move on, I actually do want to just make sure we do one of those. So let's have a look at which one that would be. That would be this one. Can you find me what the depreciation rate is in this situation? See if you can solve that problem for me. We know if it's reducing balance, it would be that formula we're using. Have a look at what I've done for my depreciation rate. I've said I nom divided by 4. Give me a thumbs up if you understand why I took the interest rate or the depreciation rate I'm looking for and I divided it by 4. Give me a thumbs up if you understand why I did that. Okay. Cool. So the reason I did it, Lorato, is if you look at the question, it says it's compounded quarterly. And when you're solving for the depreciation rate, you're solving for the nominal depreciation rate or the yearly equivalent or the yearly interest rate before you would chop it up. So it's almost like you need to divide this by 4 so that you get it into the right quarterly interest rate so that you then eventually get the correct overall interest rate. It's kind of like, yeah. Let's see how it works if we put the values in. And I want to try and figure out what this depreciation thing is. The effective depreciation. Well, yeah, the nominal, sorry. Okay, so now how do we get rid of the power of 32? We have to take this 32nd root of this. And so I'll even put a long messy value in there because it might just be useful to kind of understand what's going on. So this is going to be 1 minus I nom over 4. And then on this side, you're going to have whatever the 32nd, which admittedly is going to be a bit of a crazy number, 5830 divided by 7190. And I'm just going to put this in so that you can actually see it, but probably most of the time it would just stay in your calculator's memory. 99346 but we're still trying to get this I by itself, which is the depreciation rate. So we are going to bring the one, well, I suppose what I could do is I could bring all of this across. So I nom divided by 4 equals 1 minus all this. Sorry, that's 691,018. 691,018. And then whatever I got for that, I have to times it by 4. So this is where your calculator's memory is going to have to play a bit of a role. And I get times both sides by 4. And so whatever value you got for this in your calculator needs to be multiplied by 4. So I'm going to do that now. And then it's times by 4. And I get 0.0261,235, blah, 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 which is going to be 2.61% per annum as the depreciation. We're going to do another one like that because I think it might have caught a few of you. Give me a thumbs up if you're with me on that. Give me a thumbs down if you are unsure. Okay, well then let us do one more like that. I want you to do for me J over here. Can you do question J? Using the ideas that you've just seen used in this question. Maybe I should really zoom in a bit here. It's a bit. Let's go, team. You can do it. I know these are a little bit long, but the more you practice them, they do get easier. So what are we getting for our answer there? So our depreciation rate should be 6.98% per annum. Or 7 if you're rounding off to the nearest percentage, yeah. All right, everyone. Thumbs up if you're feeling okay. Thumbs down if you're not feeling so good. Just want to know how things are looking. It's time for one more question. So we're going to squeeze that in, but I think you've done nicely. Okay, so last question for the week is a combo question. And the way it is it's talking about a car. And often when you are buying a car, sometimes you have an old car you want to trade in. And that old car cost something once upon a time, and it lost value. And then sometimes you might have been saving some money also for this replacement car that you're going towards. So let's just look at the mathematics behind that. So it says Kai bought a new car 4 years ago. He now wants to upgrade to the latest model, right? And this often happens. Sometimes people like a particular type of car, and if they're lucky enough to earn money to replace it, they do. So 4 years ago, he also invested 60,000 Rand for 4 years at an interest rate of 9.6% per annum compounded monthly. So that's a little bit of information. And it says he will use the investment to pay cash for the new car and use the old car as a trade-in. So there'll be some value in that old car. Then it says, calculate the value of his current car if he paid 160,000 for it, and it's depreciated at 12% on a reducing balance. It also says here, round off to the nearest Rand. So this first, the green bit, which I'll leave on the side, because there's quite a few parts to this, is I want to know how much is this car worth today if when it started off life, it was worth 160,000. So it's basically saying, what is the book value or the trade-in value of the old car? So can you work that out for me? It was 4 years ago when he bought the car. So how much is it worth now? What do we think it's worth now? My calculation, maybe I'll see if you agree with me, is 95951, and it says to the nearest Rand. So I'm actually going to leave it at 95,951 if I round to the nearest Rand. So that's how much money is left. Basically, that's how much value is left in the old car. Okay, so that's part one to this question. Now, the second part of the question says, assuming inflation over 4 years is, so this is 9% per annum, calculate the current price of a similar new car. So in this case, because it's getting bigger and going into the future, I'm going to use the compound growth formula. And this car used to cost 160,000, but I want to know if I'm using an interest rate of 9%, right, per year, how much will an equivalent car cost today? Which it feels like for me, if it's going up at 9% per year, how many years? It's been 4 years. You know, tell me how much an equivalent car would cost today. And this makes sense. I know when I looked at cars, like I think, yeah, I have a Renault Stepway. I think it was about, like every year, if I look at the new car prices, they go up by about 5 or 6%. Awami, the reason we're using simple growth here is because of the word inflation. So it's basically, the question is no longer asking about losing value. It's asking that prices tend to go up in time. And because the question said, assuming inflation, inflation says that the price should increase. And it also makes sense if you think about it, like 4 years ago, it cost this much. How much does it cost now? And so that's why we're using the simple growth increase formula. There's a plus in there. And you should get 225,853.06, but then we just round it off to 225,853. Okay, so this is the cost of the new car. Then it says, the last bit, it says here, the dealer offers a 12% discount on this car. So I want you to work out, if you get a 12% discount, so that was the price, I want to know what is the discounted price. So you don't actually have to pay 225,853, you get to pay less. How much is the discounted price? There's a 12% discount. What is the discounted price going to be? I get 19875. And if I round off, it's going to be 1. So that is actually the price that the new car price that if he wants to buy a new car, that's what he has to pay. Now, we're actually going to run out of time, guys. So I'm actually going to continue with this. I'll continue in the next lesson. But basically, what was going to happen is that the person has 95,000 rands worth of value sitting in his old car. In order to afford a new version, you have to have 198,000. And the next part of this question was going to be to say, oh, he invested 60,000, right? And that grew 4 years. So how much is that investment worth? And does the investment plus the book value of the old car cover the new car? But I'll talk about that in next week's lesson. Okay. Yeah, can you put the link to the quiz in the chat? And yeah, I hope everyone has enjoyed the lesson today. I'm impressed by your diligence, and it will pay off your hard work of chopping away at your knowledge. And yeah, I think we're going to wrap it up at this point for today. All right. Cheers, everyone. So what is the method for the discount? There's 2 different ways of working out how to work out the discount. The one way is to say, what is 12% of 225? And the way we do that is we just go 12 over 100, or 0.12 times by that amount. And so that would just be 225,853. Now that is not going to be the final amount. That's how much money 27 102. That's how much we need to take away. So you could take that amount away from this one, or what you could do is you take the original 225,853 and you say if you lose 12%, you've actually only got 88% left. And so you can take the original amount 225,853 and times it by 0.8, and then you get the 198,751 when you round it off. So either you work out the discount and take it away, or you just times it by the 88 out of 100, which is 12% less than 100. Okay, Tembi, does that help? A little bit with the discount? In Kazi, the diminishing method is you have to use this formula. So the diminishing balance method would be using that formula, whereas the straight line depreciation formula is that one.